Hi, I'm Sadib Bilidi, a PhD candidate at the Colorado School of Mines working at the Mirror Lab. I'll be presenting my work with Daniel Rosen, Dan Liu, Aubrey Schick, and Tom Williams, titled Analyzing Teleoperation Interface Usage of Robots in Therapy for Children with Autism. In the U.S., 14% of school-aged children received special education services. These services can belong to a vast selection of therapeutic modalities, including talk therapy, music and dance therapy, or art therapy. While traditionally therapy is facilitated by a human, research has shown socially assistive robots to be highly effective in delivering therapy to children with autism. Specifically, robot-led therapy produces similar learning outcomes while increasing engagement with children. Engagement in therapy is crucial, and robots can help bridge the gap in making children feel comfortable. So how do these robots work in therapy? Here we have a photo of a program that's run by our partners, Fine Art Miracles, or FAM for short. You can see the children sitting in a circle with a therapist and a Misty robot interacting with a child. The therapist is using a tablet to control this robot, and they control the robot's motion and its dialogue using the PeerBots app. Here is an example configuration of the PeerBots app. In the center, you see some dialogue options for the teleoperator to select. Each button will result in the connected robot verbalizing that dialogue. On the left side, you can see buttons for the various collections that the teleoperator has loaded. This allows them to organize the dialogue options more effectively. On the right side, the teleoperator can edit the content of the options. This allows the interface to double as both an authoring and teleoperation tool. So how are therapists actually using this software? We looked at usage logs from 2 8-week programs run by FAM in special education classes. The data we received contains the dialogue verbalized during sessions, which we'll refer to as session content, as well as the dialogue options that were authored, which we'll refer to as authored content. Note that sometimes authored content isn't used in the session. We looked at all the unique instances of these options and coded them to identify key themes. With 3 coders and a strong agreement, we arrived at 5 themes: lesson content, rapport building, feedback, attention management, and ignorance. Lesson content is the key information that the operator aims to deliver. This is the therapeutic intervention and consumes the majority of the session. Rapport building dialogue aims to establish or continue a relationship with the child, and feedback options provide positive or constructive feedback about the child or their actions. Attention management content is uniquely differentiated from feedback in that the core intent is to redirect the child's attention. Finally, ignorance dialogue is used when the robot didn't have a pre-authored response. An example of an ignorance response is, "That's a good comment, let me think about that." Using these content categories, we are able to identify several patterns. First, we found a repeated order in how these content themes appeared in sessions. Sessions mostly start with lesson content, with interspersed feedback, and end with rapport building. Some sessions also start with rapport building. Second, these themes exhibit different dialogue architectures. With lesson content, there is a sequential nature in dialogue, where the teleoperator is mostly just delivering content. Whereas with rapport building, the child's response heavily influences the next dialogue option verbalized. Third, we found that while collections were used to separate different lessons, content with similar intent was duplicated both within and across collections. This was most visible with feedback dialogue. For example, buttons for good job and awesome were prevalent across collections. Finally, when examining session content, we found that robots rarely verbalize the same content more than once within a session. Based on these patterns, we present 3 key design recommendations for improving interfaces in this context. First, these interfaces should take the identified content categories into consideration by including custom views for each content category. Second, interfaces should be able to handle dynamic dialogue content that may be determined or selected during the session. An example of this would be the child's name or their favorite color that may have been a response to a question that was asked during the session. Finally, we recommend interfaces present suggested options for users to make them easier and faster to use. In summary, by examining how teleoperation interfaces are used for robot-led therapy with children with autism, we identified 5 content categories that result in 3 design recommendations, including custom views for each content category, handling dynamic dialogue content, and presenting suggestions to the user. Thank you for listening, and I look forward to answering your questions.